Hello friends, I'm going to show how FluidSIM-H can be used to develop sequencing circuits. The main aim of this lecture is to achieve certain learning outcomes as follows. Number 1, learners should be able to select appropriate components from FluidSIM library. Number 2, learners should be able to develop required sequence or the logic and simulate it. Okay, as said earlier, there are several components available in the library of FluidSIM-H or FluidSIM hydraulics which can be taken or chosen appropriately. Okay, so the sequence circuits of these find applications in the various areas like number 1, material handling, clamping, shifting, positioning, orienting. Number 2, general applications like packaging, feeding, metering, door control, transfer of materials, turning or inverting, sorting, stacking, stocking, stamping, and embossing. And number 3, in the area of machining like drilling, turning, milling, sawing, finishing, forming, and quality control. Okay, so before we start designing the sequence or the logic of these circuits, we should know what are the main components or how the components are divided in different parts of this circuit. So what are the main parts of the circuit? The first is energy supply or the aggregate, uh, which consists of a power pack in case of hydraulics. Power pack means uh, a combination of a motor, pump, and a reservoir. Okay, all these three together is known as power pack. If it is pneumatics, it will be compressor, and there would be probably a FRL unit in case of pneumatics. Okay, so this is the first part, energy supply or the aggregates. Second part is control elements or processing elements. So this part consists of different valves like direction control valves, pressure control valves, and flow control valves. And also their mode of actuation. When you open the software, you will come to know how user friendly this software is. There are different modes of actuation available. We will go through that. We can even design the logic or the conditions on which the sequence works. Then there are different types of valves based on the number of ports and the number of positions of the valves, like 4 by 2. 4 by 2 means 4 ports and 2 positions. 5 by 3. 5 by 3 means 5 ports and 3 positions. And 3 by 2 means 3 ports and 2 positions. Similarly, there are several other valves available, okay, for developing a logic. So this is the second part of any circuit. So you should ensure that this part also exists in the circuit. Okay, and the final part is actuators, which are actually controlling the load, or which act as a load. Okay, so actuators consists of pistons, which could be single acting or double acting. These are linear actuators. They could be motors, rotary actuators, and also swinging actuators. So these are the types of actuators. So broadly speaking, there are three parts of any circuit: energy supply or the aggregate, control elements or the processing elements, and actuators. Okay, so now with this I think we should be able to design any logic. Hydraulics is generally used for high loads. It can take up to 600 bars of pressure, and it can develop a force of 3000 kilonewtons. Whereas pneumatics uh, is known as low cost automation and used for lighter loads, like it can take a pressure of 6 bars and it can develop a force of 25 kilonewtons. So now let's try to explore this FluidSIM-H software. So now we have already opened this software. Okay, so let's try a sequence of say, let's take a text block here first, in which we will be typing our desired sequence. Okay, let us say simple let us take simple sequence of A plus, B plus, A minus and B minus. Okay, so this simple sequence we have taken of two double acting cylinders. So this is our sequence A plus, B plus, A minus, B minus. So there are two cylinders A and B which expand one by one and then retract one by one. This is simple sequence. Let us try how to develop this logic using FluidSIM-H or FluidSIM hydraulics. Okay, so let's choose two double acting cylinders. Yeah, so this is cylinder number 1. Let us say this is A, and we will choose say 4x2 valve as a control element. Okay, let's connect these ports, the piston side and the rod end side. Okay, now you will need some sensors here. Let us name them. Let this be S1, let this be S1, and let us also have S2. It starts from 200 and ends at 200 because the stroke given here is 200. So let us take it 200. So these are your S1, S2. These are the limiting positions rather. So S1 is the retracted position and S2 corresponds to the expanded position. Okay, so this is cylinder A. Okay, for this you will also need the mode of actuation of this valve. Okay, there are different modes of actuations available. Like here you can see it. First one is solenoid actuated. Second one is also second one is pilot operated, and third is pilot solenoid. Okay, so let us choose pilot operated valve. On both sides we will have pilot mechanism. So this is pilot operated 4x2 DCV. It will now need a pump, okay, and also need a tank. As you know, any DCV has got ports like pressure terminal and tank terminal, or the pressure port and tank port. So you connect like this. This is a pump actually. This can be shown, can be taken through a power pack also, but for the sake of convenience we will take a pump directly here. So this is your one cylinder arrangement. So we need one more similar cylinder. So what I will do is I will copy this and replicate this. So this is your second cylinder, right? Only here you need to change the actuating labels. These are actually roller switches or the limit switches, as you know. So this is your S3 and S4. This is S1, S2, this is S3 and S4 for the cylinder B. Okay, so now we are ready with these two cylinders. Now you have to develop the logic. Okay, so we have seen that there are different actuation of valves possible, different types of methods. Different valves are also available, like 5x3 valve is there, 4x2 is there, then 3x2 is there. There are several valves. You can choose anyone which suits the application. Okay, now once you have developed these two cylinders, now you have to develop the logic. Okay, so for that you need certain conditions or the logic required for that. So let us take these switches, or also called as conditions, since you should remember that the number of conditions will be equal to the number of sequences or the number of actions here. So here how many sequences are there? A plus, B plus, A minus, B minus, 4. So you will need 4 conditions or the 4 switches. Okay, these are basically valves, but these are called as switches or conditions because they are a part of a logic. Okay, so mm, for A plus B plus A minus B minus we need 4 such switches, right? Now these let us make these roller operated switches because these are limit switches, roller operated spring return. Similarly, this is also roller operated and spring return. This one also roller operated and spring return. Roller operated spring return. Okay, so we have 4 conditions of the 4 valves we have chosen to actuate these sequences, right? So now let's connect these terminals or the ports, because these 4 limit switches are responsible for developing the logic. Now to initiate or to start we will need one more such switch. Okay, so let's take it here. Let's also connect it here. Sorry, let's connect it to the pressure terminal. You need one tank here because there is one free port. Now for these 3 conditions, remaining conditions, you will also need one pump and one tank because these are open terminals. We cannot leave these open. What you can do is you can take one pump and one tank, and through that you connect to all these terminals, or you can choose 3 sets. There is no harm. So let me take one pump, one tank. Okay, so this is your set 1. So you will need similar sets. So what I will do is I will replicate this. This is set 2 and this is again set 3 for this valve. Okay, now you connect these to the corresponding ports. Here something went wrong. Yeah, correct. So this is your pressure terminal, this is your tank terminal. You are connecting this. Now you are done with the logic. Okay, now this valve is also to be, or this button is also to be actuated. Let us make it simple. Simple manually operated switch and with spring return. So this is manually operated switch with spring return. This will also need a power supply or the pump and a drain or a tank. Okay, let's connect these ports also. Okay, now you are done with the circuit. The circuit is ready, but only thing is the logic is to be properly designed. So you should remember when A plus B plus A minus B minus sequence is given, so and in default position this will be always in the retracted position. So when you have to want to expand this, what is the necessary condition? The last B minus must have been complete. So when B minus is complete, what is the logic here? When B minus is complete, that is when B is retracted, S3 has to happen, or S3 has to be true. So for A plus to happen, S3 has to be true. So you name this as S3. Okay, so this is your S3. This is S3. Now what is the next? B plus. So for B plus, A plus must have happened, or in that case S2 must be true. So here you name it as S2. Okay, so this is your S2. After that A minus will happen. So when S2 takes place, S4 is true. So this should be S4, right? And when A minus happens, S1 is true. So this should be S1, so that B minus takes place, right? So now you are done with the logic. So this is conventional hydraulics. Okay. So if you want to check if your circuit is correct, you can just try to simulate it. Go to this dark triangle. Okay. And now push this button. As you can see, this is functioning well. Now the next question is, if you want to make it multi-cycle, because as you saw here, when I push this button, it is giving you A plus B plus A minus B minus. One cycle it is giving. So if you want to make it multi-cycle, so in that case, what is to be done? So there is method for that. So this switch which you have chosen, so instead of manual, you choose it as a detent switch. Okay, only small difference, if you can see here the difference in the switch. This is known as detent switch. Okay, so you have replaced the manual switch with the detent switch, and now you try to simulate it for multi-cycle. Okay. Okay, now this is multi-cycle. So this is all about hydraulic circuit using A plus B plus A minus B minus. There are even more ways of having multi-cycle, which we will be discussing in subsequent videos. Thank you.